So hello everyone, today in this audio class we will read the chapter number 1 from the book Practical Work in Geography Part 1 Class 11 Geography NCERT Practical Textbook. So let's get started with the chapter number 1 Introduction to Maps. You may be familiar with maps that you have seen in most of your books of social sciences representing the earth or any of its parts. You may also know that the shape of the earth is geoid or three-dimensional and a globe can best represent it. A map, on the other hand, is a simplified depiction of whole or part of the earth on a piece of paper. In other words, it is a two-dimensional form of the three-dimensional earth. Hence, a map can be drawn using a system of map projection. As it is impossible to represent all features of the Earth's surface in their true size and form, a map is drawn at a reduced scale. Imagine your school campus. If a plan or map of your school is to be drawn in its actual size, it will be as large as the campus itself. Hence, the maps are drawn at a scale and projection so that each point of the paper corresponds to the actual ground position. Besides, the representation of different features is also simplified using symbols, colors and shades. A map is therefore defined as a selective, symbolized and generalized representation of the whole or a part of the Earth's surface on a plane surface at a reduced scale. It may also be understood that a simple network of lines and polygons without a scale shall not be called a map. It is only referred to as the sketch. In the present chapter, we will study the essential requirements of maps, their types and uses. Here is a small box called glossary. So what is cadastral map? Cadastral map, a large scale map drawn at a scale 1:500 to 1:4000 to show property boundaries, designating each parcel of land with a number. Cardinal points north, south, east and west. Cartography, art, science and technology of making maps, charts, plans and other modes of graphical expression as well as their study and use. Next is generalization map, a simplified representation of the features of the map appropriate to its scale or purpose without affecting their visual form. Next is geoid, an oblate spheroid whose shape resembles the actual shape of the earth. Next is map, a selective, symbolized and generalized representation of the whole or the part of the earth at a reduced scale. Next is map series. So a group of maps produced at same scale, style and specifications for a country or a region. Next point is projection map. So the system of transformation of the spherical surface onto a plane surface. Next is scale. Scale is the ratio between the distances of 2 points on the map, plane or photograph and the actual distance between the same 2 points on the ground. Next is sketch map. So a simplified map drawn freehand which fails to preserve the true scale or orientation. Next point is essentials of map making. In view of the variety of maps, we may find it difficult to summarize what they all have in common. Cartography, being an art and science of map making, does include a series of processes that are common to all the maps. These processes that may also be referred to as essentials of the maps are scale, map projection, map generalization, map design, map construction and production. Next point is scale. We know that all maps are reductions. The first decisions that a map maker has to take is about the scale of the map. The choice of the scale is of utmost importance. The scale of a map sets limits of information contents and degree of reality with which it can be delineated on the map. For example, figure 1.3 provides a comparison between maps having different scales and the improvements made thereupon with the change in scale. Next point is projection. We also know that maps are simplified representation of the three-dimensional surface of the earth on a plain sheet of paper. The transformation of all side curved geoidal surface onto a plane surface is another important aspect of the cartographic process. We should know that such a radical transformation introduces some unavoidable changes in directions, distances, areas and shapes from the way they appear on a geoid. A system of transformation of the spherical surface to the plane surface is called map projection. Hence, the choice, utilization and construction of projection is of prime importance in map making. Next point is generalization. So, every map is drawn with a definite objective. For example, a general purpose map is drawn to show information of a general nature such as relief, drainage, vegetation, settlements, means of transportation, etc. Similarly, a special purpose map exhibits information pertaining to one or more selected themes like population density, soil types or location of industries. It is therefore necessary to carefully plan the map contents, while the purpose of the map must be kept in the forefront. As maps are drawn at a reduced scale to serve a definite purpose, the third task of a cartographer is to generalize the map contents. In doing so, a cartographer must select the information or data relevant to the selected theme and simplify it as per the needs. Next point is map design. The fourth important task of a cartographer is the map design. It involves the planning of graphic characteristics of map, including the selection of appropriate symbols, their size and form, style of lettering, specifying the width of lines, selection of colors and shades, arrangements of various elements of the map design within a map, and design for map legend. The map design is therefore a complex aspect of map making and requires thorough understanding of the principles that govern the effectiveness of graphic communication. Next point is map construction and production. The drawing of maps and their reproduction is the fifth major task in the cartographic process. In earlier times, much of the map construction and reproduction work used to be carried out manually. Maps were drawn with pen and ink and printed mechanically. However, the map construction and reproduction has been revolutionized with the addition of computer-assisted mapping and photo printing techniques in the recent past. Next point is history of map making. The history of map making is as old as the history of mankind itself. The oldest map found in Mesopotamia drawn on a clay tablet that belongs to 2500 BC. Figure 1.4 shows Ptolemy's map of the world. Greek and the Arab geographers laid the foundation of modern cartography. The measurement of the circumference of the earth and the use of the system of geographical coordinates in map making are some of the significant contributions of the Greeks and the Arabs. The art and science of map making was revitalized in the modern period, with extensive efforts made to minimize the effects of transformation of the geoid onto a plane surface. The maps were drawn on different projections to obtain true directions, correct distances, and to measure area accurately. The aerial photography supplemented the ground method of survey, and the uses of aerial photographs stimulated map making in 19th and 20th century. The foundation of map making in India was laid during the Vedic period, when the expressions of astronomical truths and cosmological relevance were made. The expressions were crystallized into siddhantas or laws in classical treatises of Aryabhatta, Barahmihir and Bhaskara and others. Ancient Indian scholars divided the known world into 7 dvipas. That Mahabharata conceived a round world surrounded by water. So Todermal pioneered land surveying and map making as an integral part of revenue collection procedure. Besides, Sher Shah Suri's revenue maps further enriched the mapping techniques during the medieval periods. The intensive topographical surveys for the preparation of up-to-date maps of the entire country were taken up with the setting up of Survey of India in 1767, which culminated with the map of Hindustan in 1785. Today, the Survey of India produces maps at different scales for the entire country. So, types of maps based on scale. On the basis of scale, maps may be classified into large scale and small scale. Large scale maps are drawn to show small areas at a relatively large scale. For example, the topographical maps drawn at a scale of 1:250,000 and 1:50,000 or 1:25,000, and the village maps and the zonal maps of the cities and house plans prepared on a scale of 1:4,000 or 1:2,000 and 1:500 are large scale maps. On the other hand, small scale maps are drawn to show large areas, for example, atlas maps, world maps, etc. Next point is large scale maps. Large scale maps are further divided into the following types. First is cadastral map and one is topographical maps. So cadastral map, the term cadastral is derived from the French word cadastre, meaning the register of territorial property. These maps are drawn to show the ownership of landed property by demarcating field boundaries of agricultural land and the plan of individual houses in urban areas. The cadastral maps are prepared by the government agencies to realize revenue and taxes, along with keeping a record of the ownership. These maps are drawn on very large and such as the cadastral maps of village at a 1:4,000 scale and the city plans at a scale of 1:2,000 and larger. Next point is large scale maps is topographical maps. So these maps are also prepared on a fairly large scale. The topographical maps are based on precise surveys and are prepared in the form of series of maps made by the national mapping agencies of almost all countries of the world. For example, the Survey of India undertakes the topographical mapping of the entire country in 2000. 2,50,000 and 1:2,50,000 and 1:50,000 and 1:25,000 scale. These maps follow the uniform colors and symbols to show topographic details such as relief, drainage, agricultural land, forest, settlement, means of transportation and communication, location of schools, post offices and other services and facilities. Next is small scale maps. Small scale maps are further divided into the following types. First is world map and another is atlas map. Number 1, world map. So these maps are generally drawn on large size paper or a plastic base for use in classroom or lecture halls. The scale of world maps is generally smaller than the scale of topographical maps but larger than the atlas map. Next is atlas map. Atlas maps are very small scale maps. These maps represent fairly large areas and present highly generalized picture of the physical or cultural features. Even so, an atlas map serves as a graphic encyclopedia of the geographical information about the world, continents, countries or regions. When consulted properly, these maps provide a wealth of generalized information regarding location, relief, drainage, climate, vegetation, distribution of cities and towns, population, location of industries, transport network system, tourism and heritage sites, etc. Next point is types on map based on function. So the maps may be also classified on the basis of their function. For example, a political map serves the function of providing administrative divisions of a continent or a country, and a soil map shows the distribution of different types of soils. Broadly, maps based on their functions may be classified into physical maps and cultural maps. First is physical maps. So physical maps show natural features such as relief, geology, soils, drainage, elements of weather, climate and vegetation, etc. Next is number A of physical maps are relief maps. So relief maps show general topography of an area like mountains and valleys, plains, plateaus and drainage. So figure 1.7 shows the relief and slope map of Nagpur district. Next physical map is geological maps. These maps are drawn to show geological structures, rock types, etc. Figure 1.8 shows the distribution of rocks and minerals in Nagpur districts. Next is climatic maps. So these maps depict climatic regions of an area. Besides, maps are also drawn to show the distribution of temperature, rainfall, cloudiness, relative humidity, direction and velocity of winds and other elements of weather map. So next is soil. Next physical maps are soil maps. So maps are also drawn to show the distribution of different types of soils and their properties. Next is cultural maps. So cultural maps show man-made features. These include a variety of maps showing population distribution and growth, sex and age, social and religious composition, literacy, levels of educational attainment, occupational structure, location of settlements, facilities and services, transportation lines and production, distribution and flow of different commodities. Next is political maps. These maps show the administrative divisions of an area such as country, state or district. These maps facilitate the administrative machinery in planning and management of the concerned administrative unit. Next point is population maps. So the population maps are drawn to show the distribution, density and growth of population, age and sex composition, distribution of religion, linguistic and social groups, occupational structure of the population, etc. So population maps serve the most significant role in the planning and development of an area. Next point is economic maps. So economic maps depict production and distribution of different types of crops and minerals, location of industries and markets, routes for trade and flow of commodities, and show the land use and cropping patterns and the location of industries. Next point is transportation maps. These maps show roads, railway lines and location of railway stations and airports. Next point is uses of maps. So geographers, planners and other resource scientists use map. In doing so, they make various types of measurements to determine distances, directions and area. Next point is measurement of distance. The linear features shown on the maps fall into two broad categories. One is straight lines and erratic or zigzag lines. The measurement of straight lines, features like roads, railway lines and canals is simple. It can be taken directly with a pair of dividers or a scale placed on the map surface. However, distances are required more often along erratic paths, for just like coastlines, rivers and streams. The distances along all such features can be measured by placing a thread at the starting point and carrying it along the line up to the end. The thread is then stretched and measured to determine the distance. It can also be measured by using a simple instrument called rotameter. The wheel of rotameter is moved along the route to measure the distance. Next point is measurement of direction. So direction is defined as an imaginary straight line on the map showing the angular position to a common base direction. The line pointing to the north is zero direction or the base direction line. A map always shows the north direction. All other directions are determined to this relation. The north direction enables the map user to locate different features with respect to each other. The four commonly known directions are north, south, east and west. These are also called the cardinal points. In between the cardinal points they may have several intermediate directions. Next point is measurement of area. The measurement of the area of features like that of administrative and geographic units is also carried out over the surface of the map by map users. There are different methods in which areas can be determined. On the one of the simplest but not very accurate method to determine the area is means of regular pattern of squares. In this method, the area to be measured is covered by squares by placing a sheet or graph paper beneath the map on an illuminated tracing table or by tracing the area onto the square sheet. Total number of whole squares are summed up together with partial squares. The area is then determined by a simple equation. Area is equal to sum of whole squares plus sum of partial square divided by 2 into map scale. So the area can also be calculated by using a fixed area polar planimeter. Next point is measurement of area using polar planimeter. The area calculation is also carried out using polar planimeter. In this instrument, a measure is made of the movement of a rod whose locus is constrained by having one end fixed to a radial arc. The area to be measured is traced along its perimeter in a clockwise direction with an index mark starting from one convenient point to which the index of the tracing arm must exactly return. Reading on the dial before and after the tracing of area's perimeter will give a value in instrumental units. These readings are multiplied by the same constant for the particular instrument to convert into areas in square inches or centimeters. So this is for today. Thanks for listening. Keep listening for further audio classes. Thank you.